Hey guys, we're Team A23, and today we're going to be talking to you about rules of inference. So, let's first start by talking about what an argument actually is. An argument is a sequence of statements that end with a conclusion. A valid argument is one where the final statement follows the truth of the preceding statements, also called the premise. So, rules of inferences, which is what we're talking about today, are basic tools for establishing the truth of statements. In previous statements, we explored the case of using a truth table, such as what I've just drawn. So here's a simple example of a truth table. It's just with two variables, p and q, and it's evaluating the truth of the statement p implies q. So as you can see, for the different values of true and false for both p and q, you can see that true and true imply true, true and false imply false, false and true imply true, and false and false also imply true. So that's an example of a simple truth table, and they are useful when there's a short number of variables. However, when an argument involves 10 different variables, the table actually requires 1,024 different rows, which can be found by doing 2 to the 10. And obviously that is not a very good solution. So fortunately, it is not always necessary to use truth tables. Instead, we can use rules of inference, which are valid all the time and also relatively simple. This screencast will explore the definitions and use of 6 different rules of inference for propositional logic. So, the first rule of inference that we're going to be talking about is modus ponens. And so this rule of inference is actually pretty simple. And the definition is, suppose you have the premise that P implies Q is true. And then you also know that P is true. Therefore, you can conclude that Q is also true. So, an example of this. So let's take the premise, if you have a current password, then you can log on to the network. So we can split this into 2 logical statements. P can be the first statement, which is you have a current password, and Q can be the second statement, which is you can log on to the network. This way we have the statement if P, then Q, or P implies Q. And having the premise that P is the current password, you can conclude that you can log on to the network. So clearly this example is somewhat obvious, but it can be helpful in longer compound propositions and eliminate the need of using a long truth table. Okay, so the next rule of inference that we're going to discuss is the modus tollens. So this one is actually simple, just like the last one, and it is as follows. So we have 2 premises. The first is that P implies Q. The second premise is actually not Q. Therefore, you can make a logical conclusion not P. So in order to fully understand this, let's use a quick diagram to describe it. So we have this large circle that represents Q, and we have a circle contained within it that represents P. And the reason it's drawn like this is actually because we have the original premise that P implies Q. Therefore, anytime P is true, Q is actually also true. Therefore, P should actually be contained within Q as I've drawn it. The second premise that we had was not Q. So let me shade in the area that represents not Q. And this is basically everything within the entire space that is outside of the circle of Q, as I've just shaded. So, therefore, a logical conclusion that we can make from this is not P. So, it seems pretty straightforward, but let's just use a quick example just so we make sure that we have it. So, we have the statement, object A is not, or a cat is an animal. If an animal is a cat, if a cat, then an animal. Sorry. The second premise that we have is that object A is not an animal. Therefore, we can conclude that object A is not a cat. And obviously this follows what we described before, because P is the statement that it is a cat, Q is a statement that it is an animal. So if it is not an animal, then it is not a cat. And that's modus tollens. The next rule of inference is hypothetical syllogism. So, the basic idea of this is, first you have the premise, if P, then Q. And then you have the premise, if Q, then R. Therefore, you can conclude that P implies R. So, again, it is pretty useful to draw a diagram to kind of represent the situation. So first you have a small circle that represents P, and as before, for P implies Q, that circle is contained within a larger circle that represents Q. This time, however, Q is also contained within a circle that we call R. Therefore, you can conclude if P, then R, which is pretty easy to see once you see the diagram, because the circle P is actually contained within R. So let's use a real-life example once again to kind of model this. So since we used the cat and animal example last time, we'll just kind of keep continuing with this. So P implies Q. If object A is a cat, then object A is an animal. Now you also have the premise, if object A is an animal, then object A can move. Therefore, you can conclude that if it is a cat, then it can move. Which, again, follows exactly what you see on the left side. P implies Q, Q implies R, therefore P implies R. The next rule of inference is disjunctive syllogism. So, the basic idea of this is you have the premise P or Q. The second premise is that you also have not P. Therefore, a logical conclusion is that Q. So again, we can model this with the drawing, and again we draw a big box to represent all the possible values, but this time rather than drawing circles, we actually split the box in half. And this is because you know that the only possible cases are either P or Q. The second premise that we have is that P is not true, not P. Therefore, a logical conclusion is Q. So, let's use a real-life model to kind of make this a little bit more clear. So you have the premise that the sky is gray, or the sky is blue. Then you also have the premise that the sky is not gray. Therefore, it is logical to conclude that the sky is blue. And that's disjunctive syllogism. The next rule of inference is addition. And this one may also seem a little bit tricky at first, but it is actually quite simple. So, it follows that you have the first premise P. P is true. Therefore, you can conclude that P or Q is also true. And this is actually really straightforward, so we'll just skip straight to an example for this. You have the statement P, which says that it is below freezing. You also have the statement Q, which says that it is raining. Therefore, you can conclude that, and you have the premise also, that it is below freezing. So if it is below freezing, then you can conclude, as the addition principle states, that P or Q is true, which is the same as saying that it is either below freezing, or it is below freezing, or raining, or both, since this is an inclusive or. And obviously this makes sense because you know that if it is below freezing, then it will be below freezing or raining or both. So that's addition, so hopefully you understand that. Finally, the last rule of inference that we're going to talk about is simplification. So, The basic idea of simplification is that you have the premise P and Q. Therefore, you can conclude P, or you can conclude Q. So, let's give an example of this. So, let's say that P is I can't get a hold of money, and Q is the bank will not lend me any money. So, I've just written here the example of the statement P and Q. I can't get money, and the bank won't loan me money. Therefore, you can make the conclusion that you can't get money. So, and also going along with this, a second conclusion that you could make is that the bank will not lend me money. So this seems pretty straightforward, but it is actually quite useful because it allows you to take a larger statement, P and Q, and simplify it down to either P or Q, which can be useful in longer logical expressions. So those were all the rules of inference that we went over, and I've provided a quick recap slide. So first, modus ponens was P implies Q and P, therefore you can conclude Q. Modus tollens was you have the premises P implies Q and not Q, therefore you can conclude not P. And then there's hypothetical syllogism, which is P implies Q and Q implies R, therefore you can conclude P implies R. Then you have disjunctive syllogism, which is P or Q and not Q, therefore you can conclude P. Fifth, you have addition, which is you have the premise P and you can conclude P or Q. And lastly, you have simplification, where you have P and Q, and therefore you can conclude P. So hopefully you guys all understood all the stuff that we talked about, and I hope that this was helpful. Thanks a lot for listening.